On visual sensing for overcrowding in COVID-19 infected cities using modified deep learning, deep transfer learning methods. First of all, COVID-19 we have already familiar last 3 years, and we have seen that there is a many research paper is already published in based on COVID-19 domain. So today we'll discuss the COVID-19 with sensing methods specifically for the crowded region. This COVID-19 issues, motivation and contribution, deep transfer learning approaches and regans. First, in the introductory section, COVID-19 is circulating in crowded places as an infection diseases. So COVID-19 can be prevented from spreading rapidly in crowded areas by implementing multiple strategies. So the use of unmanned aerial vehicles as a sensing device, because of that we are extracting the data and that can be useful for detecting the overcrowding events. So here we introduce a real-time system such as congestion and abnormal behavior. So that's why this is a classified area. That is one is your congestion region, not a congestion region. Another one is a normal, like to generate the beta accuracy of the model. So that's why this is a very UAP and social monitoring system SMS enable deep transfer learning we have proposed, and it provides the overcrowding scenario specifically for COVID-19. So it improves the identification by selecting the best features. And some basic steps I would like to share. That is first, we can collect the data. And next, this data can be processed in the segmentation method, means your data preprocessing scheme. After that, your data segmentation, then your feature extraction. After that, your classification, and then you can get the predictive values. Based on the predictive values, so we can predict in the future aspects also. So feature selection is the one of the major concern for providing the better accuracy of the model. So in that case, that is your water cycle algorithm, WCA, considered in this case, and we are making the decision based on the deep transfer learning. And CCTV cameras used in society for video surveillance in crowded environment. And monitoring the crowd means monitoring the crowd from overcrowding is also the challenging because the abnormal events occur infrequently. So people's congestion may sometimes exhibit the different behaviors. So in society, the detection of overcrowding plays a big role in preventing problems such as the emergence of abnormal population behaviors. And major challenges are the detection of the overcrowding in smart environment is one of the novel social systems. and it can improve the population management. So due to the rapid growth of the urbanization in modern cities, so intelligent approaches are needed to handle the essential challenges such as civil infrastructure, healthcare, and transportation system also. So need to develop more efficient and optimal density management methods. Optimal or effective schemes is highly recommended for providing the better accuracy of the model. So we can describe the overcrowding and using the automated learning methods. So unmanned aerial vehicles are employed to address the different challenges such as the overcrowding and unusual behavior of the crowds. The first you need to synthesize the peak period having the larger population in a cluster. Crowding region is less crowd region. So it is highly the feature, you can say highly overlapped features. So network unmanned aerial vehicle detects the overcrowding and monitoring population behavior. So it control center process information by taking time, being accurate and being aware. Is that is a drones with the social monitoring systems in better prediction. Okay. And specifically the drones is known as the unmanned aerial vehicles and near the grounds. So unmanned aerial vehicles can employ it to address the challenges such as overcrowding and unusual behavior that I told you. So in that case, in this scenario, the overcrowding is controlled by making it easier to identify by using UAV sensing and computing parts. So UAV platform, here you see that is online monitoring systems, SMS, and this is the UAV sensing mechanism is there. So that's why in any type of communication systems, just I'm saying that in three parts, one is your data acquisition, and we are extracting data from the number of sensors. Suppose presently people are working on the Internet of Things. Things means your objects. So several number of objects are associated with the cluster within the clusters. So we can extract the information from this kind of objects, and we can process this kind of data through the coordinator to the next mode. So first part is the data acquisition, second part is the data communication, and third part is the data analytics. This is our common story. In that case, in the left-hand side, that is a UAV sensors are there. It is sensing the crowded informations, and these data can be processed to the deep learning node. And why we consider the deep learning, later we will discuss. In that case, the deep learning, feature selections, and overcrowding detection, that means the communication, or you can say the computing model, it's the second model. And finally, we'll observe that is how social monitoring system works in the help of the joint UAV and SMS network systems. So that's why our objective is that how to control the speed at which the COVID-19 spreads among the people. So this slide basically, actually here we consider machine learning, deep learning approaches, that means deep transfer learning. So, but in machine learning, this is the another part. There are the different algorithms that there, like you can use for particularly for classification, name-based classification, and forest structure classification, SPM also classification. But SVR and linear regression model, mainly used for regression task handling and random forest and classification regression trees classification, as well as it provides some regression results also. And the other important algorithms are their mapping used for classification for canonical correlation analysis also. Both are doing same feature extraction works. And FEPNN used for regression, classification, clustering, and feature extraction. And one class is being used for the anomaly detection. So these are the different machine learning algorithms. And we have already tested, but thing is that we didn't get the better results in ML-based technique for this particular problem. Okay, so that's why there is a deep transfer learning schemes we have considered. This is basically the machine learning techniques, and that utilizes the knowledge learned from one task to improve the performance of another related task. So in this figure, this is the source domain and target domain. So in between, you can extract the data from the source, and this data can be processed through the learning to the learning methods by knowledge systems. So that's why when you are transferring any kind of task through the knowledge, so this is known as the transfer learning method. So our source is source domain to the target domain. And transfer learning, here we transfer the knowledge extracted from one large database to another small database based on our requirement. And number two, the layers which you have learned the useful features. So here your source domain to the destination domain is there in the last figure, and target domain is there. So in between, several number of layers are associated. Through this layer, you can transmit the tasks. And you know the distributed systems, what are the fundamental of the distributed systems. And as well as you're already familiar with the networking structure, like the OSIS structure, like the transport protocol, you know. If your data strength is high, then break. And next, reassembling the data. So that's why your fragmentation and reassembling is one of the biggest part in your communication and networking sections. So similarly, in distributed fashion, here if your data strength is high, then you can break the data and create a small tasks. And these set of tasks you can transmit from source domain to target domain via is knowledge. So this is known as the transfer learning. And next, deep learning is preferred option for processing the video films data from the drones. Because of that, we are extracting the data from drone enabled UAV systems. That means this is act as a source. So we are extracting the data from drones UAV system. These data we are processing to the transfer learning schemes. In that case, the machine learning focuses only on completing the task with minimal input. But in deep transfer learning, we have chosen because of that there is set of a massive data is available at the source end. So that's why we chosen the deep transfer learning schemes. And to facilitate the social computing in smart city, deep learning combines unsupervised, semi-supervised, and supervised learning schemes. And UAV video processing is used for a wide range of purposes and provides the ability to apply and interpret the multiple events. Therefore, it is necessary to monitor various events continuously and analyze the network infrastructure. Social monitoring is becoming increasingly popular. So we need to implement the automated decision-making process with a variety of capabilities. And today, for how to handle the large data and each and every intermediate nodes, you have to take the proper decision based on artificial intelligence schemes. And at the end of the day, you can predict the adaptive decision-making system also. So that's why your automated decision-making process is highly recommended. And this is it can be based on the variety of capabilities and such as the real time and you can say means the detection of the cloud congestion uh, to be able to communicate with the social monitoring schemes. So in this study basically measures the presence of the people's congestion by analyzing the recordings of overcrowding from UAVs. So in that case, in determining the overcrowding event, our proposed technique aims to prevent the crowds and assist them in dispersing. So the decision making does not face the challenge of high computational complexity that I discussed. So additionally, the proposed architecture allows the development of an overall model based on the evaluation criteria, like uncertainty and generalizability is one. So that's why that is a you're considering the number of layers that's suggested, or you can say the proposed deep transfer learning and detailed schemes can operate in real time. So that's why we have considered a few things. Well, first, number one, we just recapitulating once again. We use source. We are acquiring the data from the drone-enabled unmanned aerial vehicles. Number one, this is consist of several number of sensors. We are acquiring the data. Number one, is it a crowded area? Yes. Is it a crowded area? No. So these kind of features we are processing. That means your in set of features. So this is difficult to implement in the machine learning. And we have started. Somebody who has said, did you implement? Yeah. That is a decision tree and random forest to implement it, but in somehow we guess they're not giving the better response, like the 76 and 79% of accuracy. So that's why that is a deep transfer model we have considered in this case. Okay. Next, the contributions. Just follow minutely the motivation and contribution of this work basically depend on the first UAV unmanned aerial vehicles and social monitoring system used to identify the crowd overcrowding, permitting the crowd to identifying the proper routes. So in that case, that is a modified ResNet architecture, the residual network actually, residual convolution network we have used, but it has the fewer layers rather than E2E models. So resulting in a faster detection process while maintaining the accurate detection. So faster detection as well as the accurate detection. But this is highly recommended for any kind of model. Because of that, as a computer engineer, our objective is should be how to give the better flexibility to the user. So that's why we need to develop means a power efficient, or if you are transmitting, that means a bandwidth efficient model. So that means accurate and faster detection is highly recommended. So in that way, a modified residual convolution network means your residual neural network, residual neural network architecture we have considered, and it having a least number of minimal layers rather than E2E. Number two, Feature selection. Feature selection used to reduce the dimensions of the extracted features. Part of the algorithm based on FAST, first classification model. Then, so number one, we are extracting the information from the ground UV. Considering deep transfer network, deep learning scheme, deep transfer learning scheme. Because of that, our input side having a large volume of features. And number three, we have considered for getting the first classification pressures and definitely to detect the overcrowding in real time. Actually, type of communication in two types. One is so in this work is fully for how to handle the real time deep transfer learning skills. So in proposed model, it can be implemented here. This system can be implemented with the deep transfer learning schemes to improve the congestion. The robustness of the decision making structure and SMS identifies the crowds may help to reduce the monitor routes. Overcrowding can make route improvement and more accurate.
mdkp.ac.in उसी में स्टूडेंट जोन वाले में देखोगे एजेंसी वाले वही सब करते हैं ना.
The precise detection of the work.
एक बार बात कर लो जैसा हो तो बता दो.
Such as your riots and overcrowding and carnival also. And we have surveyed.
भर दो फॉर्म बता दो.
But several studies with varying objectives have described the current methods for detecting and evaluating the overcrowding by the deep learning schemes. And despite the importance of recognizing the overcrowding in smart city, there has been relatively little research conducted to define the overcrowding and prevent infectious disease spread. So, a classification systems can improve the the characteristics of deep efficient architecture. So, based on the literature survey, we found that there are a lack of this kind of work available in the site. Because of that, this is going to solving the real-time problems. So that's why your deep transfer learning we have considered. Second, this is the overall structure of the proposed approach. Overall structure. Because the first here, a person monitoring congested areas for human behavior can make mistakes. So we need to use an automated algorithm to determine the overcrowding events. The data from thrown you to the next phase. That means we are preparing the video frames. Next step, feature extraction model we develop in the help of the modified residual neural network schemes. Actually, it's a and next, that is a feature selection. WCO later we will discuss what are cyclic algorithms we have used for extracting the valuable features. After that, this one is the condition. If epochs are over, yes, and then proceed to the next step. Then here is new classification model we have used and with RBF kernel, because of that many means your number of folds are, means if you work in the SVM, a number of folds are involved. And finally, this is the SVM system we have developed. And in this case, that the left hand side, the proper decision making system is also involved. This is the proposed transfer learning model. Based on extracted features, we assessed crowd scenes frames using the modified ResNet architecture. And ResNet helps extract features from the crowd scenes. And by adding 2 additional layers, improved the surface properties can be obtained. So a convolution transforms a collection of frames into a single feature map. So in the help of this equation, you see your X, L, J, that means your where L depicts the L layer. And BJ, it is shows the bias. And MJ, it represents the collection of the input mappings. Okay. And kernel means it is means bounded, there's a differentiable and it is mainly means depending the real function, that means the input should be real. That's why we are considering kernel. And probably the Euler's numbers, that is I think that is a 1 by 1 plus e to the power minus x. Okay. So in that case, that is your convolution results in the following equation. Here we can initially measure the data in the help of the kernel concept. Second, here sigmoidal function we have considered, and this sigmoidal function is illustrated in the mapping of the jth feature with the position x and y. A layer is ith layer. So Vijxy is described as follows. Here you see that is a Qj and Pi at the kernels, width and height. So whereas your Wijpq is the kernel's weight. So bias mapping function are Bij and Sig respectively. Next portion is that this is the layers. Aforementioned have the benefit for preventing the overfitting. Because of that, we therefore used to the stochastic integration layer in this structure. So additionally, the layers approximate have the benefit of the preventing the overfitting. So then, determining the biases and weights in CNN model, we update the deep transfer learning schemes to take into account in the following equations. Here C is the cost function, T is the update step, M is the momentum, X equal to total number of training samples, L mean learning rate, B mean bias, W mean weight. Because of that, in later we have added some weighting functions for normalizing the data. Next, random pooling helps prevent the overfitting problem. So in that case, you see it improves the detection of the pixel occlusion of the input frames with overcrowding. And P probability is evaluated according to the following equation for each jth region. So Pi equal to alpha I, sum of k, it belongs to the Rj into alpha k and minus 1. So Rj is the pooling region J in the mapping of the property. C and I is the index of each element within. It's the equation basically, and if you do the coding part, and that time you will be understand the total point. That means your random pooling methods. And what is the importance of the random pooling method? So important mean it helps to prevent the overfitting of the model. Okay. Next, your random functions used to measure the activation of each neurons in the spatial coordinates like P and Q in the K feature mapping and L layer with UJ as the weight window function. That means one rank function we have associated with this for generating the features. Okay. So in that case, your alpha P, alpha P Q to the L and K is the output of the activation function, and which accelerate the convergence of the convolution neural network. Okay. See the diagram. Probably one structure is there. Here means you will understand the total features. In this case, you see the residual block. Here the residual block is formed of means the proposed, basically this is the proposed residual neural network is based on 3x3 VGG architecture. Yeah. The 3x3 VGG architecture, and the residual block is formed of two 3x3 convolution layer. Means layers will constitute number of output channels. Yeah. So after each convolution layer, the normalized batch layer and RELU activation functions are applied. So after adding the input, the second convolution is performed before the final activation of the RELU model. Yeah. So using this method, the outputs of two convolution layers must be concatenated into a single input. So that's why at a result, that is an increased number of channels is needed. So that means you see point B, like in this one, here there's a 1x1 convolution layer will be needed to change the input and do the addition. So that's why first two layers of the ResNet are based on Google Net. So rest you see here the 7x7 convolution layer with 64 output channels. Like you see here 64 mentioned this one, 64 output channels, and a stride of 2 are followed by a minimum 3x3 collection layer. 3x3 your collection layer, and 7x7 is the convolution layer with 64 output channels were considered. Okay. So that's why in this proposed structure of modified ResNet for feature extraction. So number one is general structure of blocks in ResNet, and point B the structure of blocks in ResNet with a 1x1 convolution layer. And number three, this is the dilated layers are used to skip the extra computation. Actually, many computation happen. So here the objective is that how to minimize the complexity of the model, how to minimize the computational time. So in that case, we have used the dilated layers. So that means the number of iterations is the extra computation. Okay. Next year, feature selection. So feature selection steps use the Waters cycle algorithm, WCM, and which is inspired by the nature's water cycle. So using this algorithm, there are the following 5 main sections are there. One is the evaporation process, compaction, precipitation process, localization of water and production of surface water flows, and formation of reverse water that enters the ocean. So fluids means this is the lower layer, and surface means this is the upper. So that's why fluids and surface layer, fluids and surface water vapor considered the most effective approach to find the highest quality global features. So I informed you earlier, because of that feature selection in any work is the big job. If we people consider only 2-3 lakhs data, hardly 2-3 lakh, not data, 2-3 lakh feature value, but they are showing the nights they got means more than 95% accuracy. So I thought that is how is it possible? So my point is that first to increase the training samples, first to generate the number of features more than 10-15 lakhs. That's for your requirement is really. After that, we apply the classified model. So that's why in that time you will feel that is this result is accurate. Suppose you got 88%, that's happy. And you can happy it, okay, it's better. In that case, if some of the in other people I have seen work basically for feature highly overlap and less overlap. So anyone you can say no, sir, less overlap is better. So in that case, you can use the case density plot. Okay, that means you can't. And in that case, that is you will say that is you will consider only the less overlap features. So less overlap features is highly recommended rather than your means, fully overlap features. So that's why that is in this case basically that is how to preserve the highest quality global uh, features. So in that case, that is the water cycle algorithm we can consider, and in capacity is determined by how deep. Deep means higher its value. So essentially, the capacity of our pits is described as follows. In the next equation, you can see here the capacity of all the pits is described as follows in each group iteration for optimization. So here you see that is a one constant term is there. Another one is the min max value is also there. So based on the variation of constant and as well as your min max, so you can easily find out the better global feature value. Okay, so in this equation, the value of y is equal to the value of the ith bit, and constant is considered a value of consistency basically. So 18 and n max is assumed for smallest and largest value that created for the bits respectively. So the value of constant is also shown based on the maximum capacity of bits and in accordance with the objective function. So also CI is the capacity of the bits and that enter the large bit with the number of raindrops falling from the small bits. Okay. So this is the means one of the proposed method for measuring the feature selection stage. On the other hand, the capacity of one pit is transferred to other pits if the raindrops in one pit exceed its capacity. So therefore, your water is poured into the pit on the surface. So pit I is randomly selected among the existing pits with higher capacity. Clear? The priority is the greater of the capacity of the pit. So more likely it is to be selected. So condition, if the search space for the answer to the problem is a vector D, okay, that means it accesses the velocity and position of droplet I. So that's why this is the one of the important equation. In that case, you can find out Pi and Xi means provides some data on current velocity and position of the droplets respectively. Okay. Next, this is the algorithm. Yeah, WC algorithm or water cycle algorithm. Here you see the input, and it consists of the extracted features from the modified residual neural network structure. So the first output is the best selected feature surface. And this is the loop basically. The first loop while stopping criteria do not means not meet. So then continue with stopping criteria means And just I'm saying one thing. Suppose one other work means I have done on the markup decision process. This is the MDT. MDT, this is the stochastic modeling, and that is two. Means one graph is there, that is a monotonically increasing function, monotonically decreasing function. At a time when they can meet at a particular point, this is known as the convergence point. So convergence means the gain. You can find out the gain from this particular convergence point, where stopping criteria meet. If stopping criteria is not meeting the requirement, so that case you can process the data to the next step. So in that case, that is you need to initialize the parameter like a cost function in feature selection method. And then initialize the parameter and then associated with the WCS or NCR and index and pop and maximum iterations. So for each render of the optimization model, so then select the random subset of the features. Because of that, already we have used one random function for generating the number of features. And then you can apply different sorting algorithm for feature based. Evaluate the cost function by seeking C of K. So if the new value is greater than old, then replace the policy. Okay. New value means your present data can be verified from the past data. If you are getting the better result, then just replace it. Then move to the another view. Then again apply it. Again you are getting reassign again. Again you will find it. So that's why every iteration, end of the day, you have to find out the better result. And this set of result you need to choose as a best global features specifically for your problem. So then replace the position. Replace position of river with the sea. So if the evaporation happened and then the raining is happening, so increasing the Dmax and discover big hits. Next ended. And finally see you just getting the results. That means the global answer. Global answer means you are getting the best result. And then you can update the two parameters. One is your VI, another one is the XI. The current velocity and position of the droplet respectively. So that's why in the help of the WC algorithm, this is the one the Google algorithm for selecting the features. So selected features from the feature vector extracted by the residual neural net model, and this PC algorithm gives the most suitable set of features. Okay. Next. So part one, we have discussed data acquisition. So we are encoding the data from the drone UAV SMS system. Clear? Number two, this data we have processed through the deep transfer learning scheme. Question is why? Because we are having a large number of attributes or values in the input side. So that's why in somehow we felt that is rather than machine learning techniques, deep learning schemes performs well. But when we are transferring a different set of tasks from source to target location through the knowledge base method, knowledge base intelligent method. So that's why we consider the deep transfer learning model. And later, in this case, that we used the SVM scheme in the classification proceeding. If one training data set is given, and easy D attribute means D, it depends on the D-dimensional space. So in each point, it's supposed to have Y matching value. Okay? So that means a function that relates the input and output that can be found in the help of this equation. If xw equal to b plus wt to x. So function A requires that the values of w and b. Okay. So in that case, that is you can measure the classified result using the working function. And I informed you earlier. So voting function we have added because of that for normalizing the data. Anyone can ask asking the user why you are normalizing the data. What is the need of the normalization? Yeah, you see the good question. Because of that, that is we are considering the crowded and non-crowded data. Crowded means the large volume of data. Which is you just imagine. Later I will show you in this one figure actually. So that's your SVM function, like your F, can be formed by solving the this kind of equation for utilizing the kernel function. Okay. So some parameters we have considered. And I think that is all of you aware regarding specificity, accuracy, and sensitivity. In this two data set we have considered two data sets. One is your UMN data set, and another one is the UCSD data set. So in the first target, that is specificity, accuracy, and sensitivity for each frame of the proposed structure in overcrowding recognition systems. Here you see the number of video frames within bracket is the density. Column 2 is the specificity, accuracy, and sensitivity. Two data set we have considered. That is means your UMN. UMN database congestion is low or high. If low, these are the results. If high, these are the results. So UMN dataset includes that means the starting point, and it includes the 11 video frames and from the 3 different locations. And UCSD dataset, including the pedestrian path footage actually.
Excuse me, sir.
Hello.
Yes, sir.
Ah,
Can you please start your webcam for 1 minute? We have to take one photograph.
you can take break.
All of you, please start. Chinmay sir, please start your webcam.
Okay. Point and includes the 11 video frames and from 3 different locations. And at the beginning of the video, the crowd of the people performs the everyday behaviors in a medium density location. And another data set is the SD data set. It includes the path footage with the medium density and path model. Okay. So overall, the data set contains 48 training videos and 50 test data. Next, the one example like your charger, batteries, controllers, and ground monitoring systems are included with the UAV cameras along the stabilization. And October is equipped with the global positioning system, altitude controller, a high definition camera on the underside of the UAV captures video in the progressive frames. Actually, this is the process basically. And it considers the Sprint mobile network and broadband network of the UAV ground station to upload the captured video to the cloud platform and social monitoring systems. And last point is the using the communication channel and protocols. The user or data processing centers receives the information. See the results. Here the sample frames from two data sets. One is UCSD and UM. And this proposed model was able to detect the presence of overcrowding in many frames as a red and green. Green box means that is a no overcrowding. Red box is also shows the overcrowding in the frame data set. So you see your red color means this is a crowding region is a heavy crowding region. And green means this is the least crowding is there. So that means to listed the degree of response diversity. So here a random folds of test data from the UMN and USCD data set is presented. That means the average values of each folder Means you can consider like for the confusion matrix later I'm seeing it. I see. This is the one two data set. This is the UMN data set. Here UMN data set one is ANOR means the normal case and overcrowd. That means this overcrowding classes are there. So that's why the fold one. I inform you that the 10 folds are there. So human data set fold one, human data set fold two. Here you are getting that 97.91 average accuracy. Okay. And how to measure the accuracy means your YOLO, you just sum and divide by 2 is the confusion matrix as also. It's a very easy confusion matrix. And from this point of view, we can measure the accuracy and your diversity, the plus minus. Like this one, basically your mean and mean plus minus standard deviation. So that's why this is the representation of the UMN data set. Okay. Similarly, for confusion matrix for overcrowding region, and in the UCS data set, here average accuracy 83 point some 84 something 84 78 and this one is 85.70% and diversity is plus minus 3.11. Okay, some formula is there, you can find out in means Google also. Some formula is there, and based on this you can measure the confusional matrix you can draw it. So based on the confusion matrix, and then you can generate the data. Okay. Next, confusion matrix means in that case that it is above figure. Basically, this is the proposed model and ability to detect the overcrowding using the normal and overcrowding classes that we discussed in the last 2 slides. Basically, so confusion matrix representation is used to display the average value of his mode. It is displaying the average value. Yellow, it is a human database, and green, that means UCS data set. That means the confusion matrix representation basically is used to display the average value of the model. Based on the average value, that we are measuring the accuracy of the model. Each and every step having accuracy, some accuracy, and then you just average it because the number of folds is 10. So that's why we say that is the average accuracy. And based on the modified residual neural net model, your area under the curve. First part is AUC, area under the curve. Another one, the receiver operating characteristic, that means ROC. This is the 2 parameters. One is area under the curve of receiver operating characteristic, ROC curve. For various cloud setting improves considerably in this case. So according to the ROC, which are based on a large number of variables due to the overcrowding, so the methods its performance is compared with other feature extraction method, including VGG19. This is the other feature extraction techniques like the VGG19, your dense net and rest net. So it is also important to consider the crowd conditions. If you are thinking, sir, why you are using in this net? Because of that, we are handling the massive number of data. First, so that's why we use that is unmanned aerial, radial, drone assisted sensor systems and social monitoring systems basically. So low and high density overcrowding is measured in this case, and is successfully able to generate the AUC, that means area under the curve, and that were satisfactorily in all cases when using the modified race. And you can say that the modified ResNet provides the data structure. Okay. And that is your means TPR, respect to the means true positive rate and false positive rate. So RSC curves demonstrate the high AUC rate of the proposed model in abnormal behavior in the detection of the both database. Okay. And high density and low density cases. Secondly, for another data set, you can see that the UCSD, here low and as well as your high density case. Here you see that the modified trace net provides the better response. And average processing time. You see that in the one point is that your average processing time. Average processing time means going to the next slide. I think that is yes, yes. Yeah. You see here you see that is on data set APT means average processing time, ACC means accuracy, AUC means area under the graph. Okay. So first the average processing time in APT of the algorithm in the decision section was measured in other experiment as well as the computational complexity of the algorithm. Okay. And based on means this data set, the modified residual neural net methods was compared with the similar approaches such as the VGG, DenseNet, and regular ResNet also. So to verify the real-time methods, for number one, that is just keep in mind we are handling the large volume of data as an input. That's why we are considering the deep transfer network model. And number two, we are dealing the real-time data. We are not dealing with the stored and forward approach based data. Yeah. So that's why in that case, the response time of the trained network is estimated by applying a set of frames. Okay. So that's why in I think milliseconds, standard when time standard means APT, ever processing time. So most common units of the measurement in the real-time response of the millisecond, a microsecond also. So network computing, however, has significantly reduced the problems in the real-time processing today. So in sending information to social monitoring system, the real-time system are important for data delivery, but data processing to the one step to another step. So that's why in terms of for dealing with the above problem, in that case, APT, average processing time, accuracy, and area under the curve, we have considered under the different crowding condition scenario. Clear? And these proposed algorithms actually it averages 170 milliseconds. It takes 170 milliseconds to determine the overcrowding. And the sample data set experience with the real-time response is 170, 117. Another one is the 143. Actually, 145.5 milliseconds actually. And first one is the 117, 116, 116.57. Okay, so this is general feature 117 millisecond. Because of that, our target to minimize the computational time for complexity. So that's why our beauty in this work, basically main beauty is that is how to optimize the feature value. Okay. So a simple data set experience in real-time response, like 117 and 143 milliseconds respectively. So by changing the frame, the average processing time values are almost identical. You see the results that your APT values mostly same, nearly same you can say. So because of this change in the population density, the suggested method may take longer to track. Okay. So in comparison with the E2E model, E2E model already we have discussed in the first after 2-3 slides later. And comparison of E2E structure, the model generally used for the feature extraction by deep learning schemes, feature selection, classification, and these feature selection can reduce the processing time and also minimize the computational complexity of the model. So far, no method has been proposed that can detect the overcrowding through combination of the UAV and an SMS platform. That means whatever we have studied, and we have seen that no one is considered to detect the overcrowding cases in the combination of the drone plus means your unmanned aerial vehicles and social monitoring system platforms. Okay. This is another result because of that, and all of us means we know when we are writing or proposing something, and we need to compare means proposed work with the existing work, and in that case, that is one biggest problem is that people are using the different database. Database data acquisition is the big problem. But we followed means the standard database, two dataset name already we have mentioned. And these related papers somehow they taken the data, they generate the feature value based on those database. So that's why in here that is a Sing ETL, it proposed the aggregation of the ensemble model and the accuracy the 95%. And your computational complexity is too high. Okay. Actually, in that case, your number of if you minutely follow this paper, and definitely you will find they consider the less number of features. Okay, but thing is that better consider the large volume of better you generate large volume feature value running samples, and then you can apply the test layer. So your accuracy and complexity is the basis for measuring the overcrowding in video images, and it compared the results obtained from the proposed method with those similar approaches. So that's why in the first paper, you see that the aggregation of the ensemble models provide 95.25% of accuracy, where your complexity is too high. Next, you see that is a ETL proposed STCAE model. For somehow in the overcrowding cases, he proposed the 95.5% accuracy, and computational complexity is middle. And ETL recently they observed the 94.4% accuracy they proposed, and model is the anomaly net provided. Somehow it related to the DNM method, but complexity is too high. Because of that, and I have seen that is a they not finalize the global feature value, they're not extracting the global feature value. This is the main problem. If you do, and then they can get similar, almost nearly same value or near par value related to our results. And our proposed model, this is the modified residual neural net model. It gives the better response in terms of the accuracy, like 96.55. Complexity is middle. And our objective is that how to minimize more complexity level in future aspect also. So that's why your proposed improved ResNet model increases the robustness of the decision-making framework. And proposed approach is robust enough to handle the overcrowding scenario. So which allows the social monitoring systems to recommend the optimal routes and prevent the COVID-19 from increasing. So that's why some terms that is here is mentioned. The social monitoring schemes. Where questions, suppose anyone is asking, say, where you are storing the data? Yeah, this is a good question. Two things. In previously, we are storing we store the data directly to the server. End of the day, we realized that if we store that is an every data to the server, that means end of the day that is beyond the capacity. So that's why we are nowadays we are processing each and every data to the cloud computing, the cloud. And you know this is your computing domain, like means the cloud computing, fog computing, edge computing is there. It's the most efficient computational schemes and computational technologies involved. So that's why we are storing the large volume of data by any kind of data directly to the cloud. Easy to access. If you do coding in the Python, you know that is among the four module. Last module, the data visualization. Data visualization nowadays is the big challenge. So that's why we process our data to the cloud computing, stored in there. So that's why you can easily handle and you can easily develop your own model based on this kind of feature value. We are having a large set of features, or you are having a means your many options. So then you can choose easily. Yeah, okay, this one is better. So that's why that is a in our approach basically how to give the flexibility in terms of the quality, in terms of the maintaining the quality, in terms of how to improve the performance level. So performance evaluation, this is the main term. So each and every block we have added some intelligence. So why if this one is not okay, no problem. You just restart and again you can try. Okay. And so in this structure, basically means we have discussed means for finding means social monitoring system means you recommended in the last one the optimal rules and it prevents the COVID or increasing matter. And next, this one is summary. In this case, according to the analysis of the UAV videos or drone UAV SMS model, we achieved average accuracy. Why average? Because of the number of folds is 10. The proposed approach capable of detecting the overcrowding based on UAV videos frames and social monitoring systems, communication, even the challenging condition. And one means another point, just I'm just adding, which is somehow the discussion. I believe that is we all are learner. So that's why for my experience point of view, I can see that in communication point of view, what are the challenges of the communication when you were transmitting the video? Arm is there in the convergence network. Slightly I'm shift to the means your deep learning to the network basically. So don't take it otherwise. Actually, this is the one of the major challenges for processing the audio video data. That means this is this is in your convergence model, it consists of 3 parts: audio, video, data. Video means it's transmitting the frames. Each and every frame, it is having a large set of the pixel information. Ever question 2. So what is the major challenges for transmitting the UAV accurate data as a video frame to the channel? Number 1 is the noise. Number 2, that means if during transmission, suppose your data can be lost, or your error detection, error correction, so many schemes are there. Main issue is there, you need some bandwidth of the channel. Just think, all of you award the equation capacity equal to bandwidth into log of 1 plus SNF. The capacity over bandwidth, this is known as the bandwidth efficiency eta. So our objective is that how to improve the bandwidth efficiency. So why video frames? Video frame, audio, video data. If you're transmitting data, there is no problem. You are sending the audio signal, there is no problem. Video means that means the multimedia content is also involved in this case. That means your feature value is the mixed feature value is there. They totally ignore the feature selection strategy and just applied they collect the data, then apply the data pre-processing scheme. One filtering scheme is okay, and then go into the segmentation. They apply it and extract the original information from the background, and this data is processed to the directly to the what your accuracy is why more than 96, 98, 99, 99, 98, 99, right? First you build your data, first you generate your number of training samples. If you are having a large train data, then definitely if you achieve the 88% accuracy, so that's how we are happy. Okay. So that's why that is in few things, that is what is the main challenges of the UV video frames for transmitting through the channel. Another one for social monitoring scheme. Social monitoring scheme means this is end-to-end. If we are handling the data through the packetized domain environment, packetized this environment. So in that case, that is your end-to-end data, source to destination. In between your communication path is involved. Okay. So that's why your social monitoring scheme means our left-hand side having the data acquisition module. In this data acquisition module, basically, it consists of what type of sensor? Like a UAV sensor. So how UAV works? That is a drone associated with this. So that's why drone plus UAV plus SMS. It generates video frames. These data we are processing to the next step. Okay. So that's why your UAV and SMS are increasingly being deployed for a range of applications. Range of applications such as your event monitoring and population dispersal. So that's why to prevent the COVID-19 from the spreading rapidly. So to assist the SMS, which is social monitoring system that use a deep modified residual network structure to learn the inferred patterns to improve their performance. The next point is our objective, that is how to control the spreading over the crowded region. So based on our automated model and design to minimize the overcrowding in various places. So in that case, we developed the effective technique to respond an abnormal incidents through social computing. So abnormal behavior, that is the overcrowding scenario, can be generated from the abnormal behavior of the population. Okay. So this technique does not involve the direct involvement of the individuals. So to find effective routes during the crowding, and here we used UAV and SMS based method. Okay, on rapid algorithm to perform and process the information gathered from population behavior. Okay. Next, it's the another part, like the several social system purposes can be met by deploying and implementing the proposed model in smart city. And nowadays people are talking about the smart city. If you search in the Google, so many papers are available in the smart city. But what is the beauty of the smart city? Smart means the AI enabled systems. So each and every model, if you do something innovative, in that case, you need to implement the one term which is known as the intelligent or smart or AI. And at the end of the day, adaptive decision making unit is highly relevant. Okay, and the question is, suppose anyone is asking, sir, this model is constant? No. Network model is any network model is constant? No. It is recommended? No. Based on your requirement, you can design the model based on your usability, based on your feature. Okay. So a modified version of your residual neural net structure frames that originating from the UAV networks. And this is, first in that time thought it will be highly possible, but it is highly recommended for our society also. That is for discretized data based on the population size. Okay, and we inform that DJ means our accuracy of the data and whatever we. Another theme is that the capability of the model in real time is the another achievement of our novel study. Because of that, I inform you that your data communication can be categorized in two parts. One is your real-time data, another one is the student forward data. But we are extracting the data in the real person because of the drone already informed. So that's why this is our another novel strategy for considering the real-time data analytics also. So through this constant and in that case, that is to improve the accuracy and reduce the processing time. This is our future goal. Because of that, we can't say that our model is best in terms of the complexity. No model is best. So that's why you can defend any time. But thing is that at the present time, so whatever means the output of our result, it is superior because of that there is no competitor at the time. But definitely, if you build up your model using, suppose here even an USD2 data set we have considered. If you add more data set, if you develop your own benchmark database, and then definitely you can get, but it will be better if you increase the large feature set. So that's why in future our target indefinitely it will be how to minimize the complexity of the model, how to minimize the computational time, and how to improve the accuracy. Okay, and as well as which is the reducing the your processing time. Okay. So overcrowding the scenes, the overlapping of the people and non-human objects, the challenge of the occlusion of the pixel and some of the constant. So different points are there, and our means we are involved here through the online mode, and it will be better for the offline. So that's why you means we can interact more because of that. I believe that is all of you having much knowledge related to this domain. So in that case, that is I can learn from you also. So I missed this work actually belongs under the smart city. Okay, smart city. And here DNN model means DL model is considered for giving the better performance, and as well as you work tremendously on the feature for choosing for selecting the global best feature values in the help of means your water cycle algorithms and steps already we have mentioned. And number two, real-time session data we have considered, and this one basically. Now, means if you have any query, you just ask me. That's why we can discuss also.